Good evening, everyone. I am Bhattu Praneeth Kumar. Today I'll be presenting the topic types of batteries and their characteristics. First of all, let's talk about the contents of today's presentation. I'll be first introducing what batteries are and then talk about the various types of batteries that are present. We'll then be comparing primary and secondary batteries and then talk about them in depth, giving examples of each. And then we'll be finishing off today's presentation with explaining the characteristics of a good battery. First, before talking about what batteries are, we are supposed to talk about what electricity is. Electricity is the energy used to power various devices, and this electricity is derived from electrons. The flow of these electrons is called current, and voltage is the work done to enable this flow of electrons through a circuit. A battery is primarily considered a voltage source, meaning it provides the potential difference that drives the flow of current through a circuit. A battery is a source of electricity that is a combination of one or more electrochemical cells. The positive terminal of the battery acts as the cathode, and the negative terminal acts as the anode, as we can see in the diagram here. The negative terminal releases electrons which flow through the circuit to the positive terminal, triggering a redox reaction. This process converts high energy reactants present in the battery before any chemical reactions occur into lower energy products supplying electrical energy. Batteries convert chemical energy directly into electrical energy. In many cases, the electrical energy released is the difference in the cohesive or bond energies of the metals, oxides, or molecules undergoing any chemical reactions. A battery consists of some number of voltaic cells. Each cell consists of two half cells, connected in series by conductive electrolyte containing metal cations. This electrolyte is used to enable flow of electrons from one half cell to the other. There are mainly four types of batteries: primary batteries, secondary batteries, reserve batteries, and fuel cells. Primary batteries are those that are disposable. They are only one use and cannot easily be recharged, and then therefore they are discarded. Secondary batteries, on the other hand, are batteries that can be easily recharged by simply applying a reverse current. Reserve batteries are batteries in which one key component of the battery, which is needed to cause chemical reaction, is kept separated until just prior to activation. Fuel cells, the active material, are not an integral part of the battery, but they are fed from an outside source. Next, we'll compare primary and secondary batteries. Primary batteries are single-use and non-rechargeable. Secondary batteries are rechargeable and reusable multiple times. Primary batteries generate energy from a one-time chemical reaction, whereas secondary batteries undergo reversible chemical reactions, and therefore they can generate that electrical energy multiple times. Primary batteries have a longer shelf life with minimal power loss, whereas secondary batteries have a shorter shelf life but longer use due to the ability to recharge. Primary batteries have a cheaper initial cost but costly over time due to replacements. They have to be discarded. Secondary batteries, on the other hand, have a higher initial cost but are cheaper in the long run. Primary batteries are not eco-friendly as they are discarded after one use, whereas secondary batteries are eco-friendly by reducing battery wastage. Next, we'll talk about the different types of primary batteries. First type of primary battery is the alkaline battery. These are commonly used in a wide range of electronic devices such as flashlights, remote controls, and toys. Unlike traditional carbon zinc batteries, which we'll talk about in the next slide, alkaline batteries use an alkaline electrolyte, typically potassium hydroxide, as we can see in this diagram here. These allow for higher energy density and a longer shelf life. The main chemical reaction in an alkaline cell involves the movement of electrons from the zinc anode to the manganese dioxide cathode through an external circuit. This chemical process produces electrical energy which powers devices. Alkaline cells are favored for their reliability, relatively low cost, and longer lasting power compared to other types of disposable batteries. Apart from this, alkaline batteries have higher voltage output, typically 1.5 volts, and are more resistant to leakage, making them a popular choice for everyday consumer electronics. Zinc carbon batteries. These are the most elementary types of primary batteries present in today's world. Zinc carbon batteries are a type of primary battery that use zinc as the anode and manganese dioxide as the cathode, as well as the acidic electrolyte, usually ammonium chloride or zinc chloride. They have lower energy density compared to alkaline batteries, making them suitable for low drain devices like clocks, flashlights, or remote controls. These are inexpensive and widely available in today's world, but they generally have a shorter lifespan and lower capacity than alkaline cells. Despite these limitations, they're a cost-effective option for devices that don't require long-lasting power. Next, we'll talk about secondary batteries. The first type of secondary battery is a lead-acid battery. First invented in 1859 by French physicist Gaston Plante, lead-acid batteries are one of the oldest and most widely used rechargeable batteries, known for their reliability and cost-effectiveness. They consist of lead dioxide, the positive plate, and sponge lead, the negative plate. The electrolyte in the middle is sulfuric acid, which facilitates chemical reactions, store and release electrical energy. These batteries are commonly found in automotive applications such and as well as UPS and industrial equipment due to their ability to deliver high surge currents. Despite their affordability and recyclability, they have a lot of drawbacks, such as relatively short lifespan, heavy weight, and the need for regular maintenance in non-sealed version. The sealed version of a lead acid battery is known as SMF cell, which we'll come to later in today's presentation. Lead acid batteries remain a popular choice for applications require dependable and economical energy storage. Nickel cadmium batteries. These are a type of rechargeable batteries known for their durability, long cycle life, and ability to deliver consistent power output. The positive electrode of a nickel cadmium battery is the nickel oxide, nickelic hydroxide, whereas the negative electrode is cadmium in this battery. The alkaline electrolyte, typically potassium hydroxide, enables flow of electrons. Nickel-cadmium batteries are widely used in applications such as emergency lighting, cordless power tools, aviation, and medical equipment due to their high discharge rate and ability to function well in extreme temperatures. However, nickel-cadmium batteries suffer from what we call the memory effect. Memory effect is due to partial recharging of a nickel-cadmium cell. Due to this, the nickel-cadmium cell then won't fully recharge in its next charge as it remembers the previous charge to be its full charge condition. Additionally, cadmium is a toxic heavy metal, making disposable and environmental concerns a significant drawback. Nickel-cadmium batteries are still preferred in specialized applications where ruggedness and reliability are essential to the job. Next, we move on to nickel metal hydride batteries. These are a type of secondary batteries that improved energy density and environmental benefits compared to the nickel cadmium batteries due to the lack of cadmium present. They use a nickel oxide hydroxide positive electrode, a hydrogen absorbing alloy as a negative electrode, and an alkaline electrolyte. Nickel metal hydride batteries are widely used in consumer electronics, hybrid vehicles, and power tools due to their higher capacity and reduced memory effect compared to nickel cadmium batteries, which means that they are easier to recharge. They also have a lower environmental impact since they do not contain toxic cadmium. However, nickel metal hydride batteries have some drawbacks, such as higher self-discharge rates and sensitivity to high temperatures, which can reduce their lifespan. Despite these limitations, they produce balance between performance, cost, and environmental sustainability. Next, we come to the most popular secondary battery in today's world. We see these in a lot of electrical cars these days. The lithium battery. Lithium-based batteries are among the most advanced and widely used rechargeable energy storage solutions today, known for their high energy density, lightweight design, and long lifespan. These batteries operate by the passage of lithium ions from the cathode to the anode. The cathode is typically made of lithium cobalt oxide, lithium iron phosphate, as well as the anode or other advanced materials. They are commonly found in smartphones, laptops, electric vehicles, as previously mentioned, and renewable energy storage systems due to their efficiency and fast charging capabilities. Unlike older batteries, lithium batteries do not suffer from the memory effect and have a lower self-discharge rate. However, they can be sensitive to overheating and require built-in safety mechanisms to prevent issues like thermal runaway. Regardless of their higher cost, lithium batteries continue to dominate the market due to the superior performance and growing applications in modern technology. However, they seem to have a very promising future, as with ample research being conducted, these few drawbacks that we have present here might seem to disappear in the future. Now we move on to a variation of the lead acid battery, which is the SMF battery. As previously mentioned, in the lead acid battery, uh, okay, batteries are SMF batteries are a type of lead acid batteries designed for convenience and durability, requiring no regular electrolyte top-ups or maintenance. These are these are because this battery is completely sealed from the outside. Therefore, it requires no top-up, such as whereas in lead acid batteries, you need to keep topping up distilled water to enable the reaction to keep going on. These are completely sealed, preventing leakage and minimizing gas emissions, making them safer for use in enclosed spaces. SMF batteries are again commonly used in applications such as uninterruptible power supplies, UPS, emergency lighting, telecommunications, and automotive systems. While SMF batteries offer advantages like long service life and reliable performances, they tend to be more expensive than the average lead acid battery. However, their maintenance-free nature and enhanced safety make them a preferred choice in critical power-backed industrial applications. Next, coming to the final topic of today's presentation, the characteristics of a good battery. First is the nominal voltage. This is the voltage of a battery is designed to operate at, typically stated in volts. For example, 6-volt battery, a 12-volt battery, or a 24-volt battery. Battery capacity or battery life. Battery capacity is the total energy stored in a battery, whereas battery life is how long the battery will last for. Specific gravity of a battery. Specific gravity of a battery refers to the density of the electrolyte compared to the density of pure water present. Specific energy, which is measured in watt-hours per kilogram. This indicates energy stored per kilogram, affecting battery weight and efficiency. A good battery will have a higher specific energy than a not so good battery. Electrical characteristics includes voltage, capacity, resistance, and charge discharge rates. Voltage is the potential difference used to cause the flow of electrons known as current. Capacity is the amount of energy stored in a battery, as read here. Resistance is the characteristic of a battery to oppose this flow of electrons. Charge and discharge rates is how fast the battery recharges or discharges whatever energy it has. Battery efficiency. This is the ratio of usable output energy to input energy. This is typically 70 to 95% of an average for an average battery. Thank you. The future is electric. Thank you. That's all.